The photon led to the development of a new field in physics, quantum physics. Something very unique about quantum physics is that it is probabilistic, not deterministic. A deterministic experiment will always yield one result. Take this dice for example. Every side has the same number on it, so no matter how many times we toss the dice, we will always get the same result. A probabilistic experiment will yield multiple results, each result having a certain probability of occurring. If we toss normal dice, we can't predict exactly what number we will get, but we know the chance of getting a certain number, or the probability. So how did the discovery of something as simple as a photon lead to the development of a probabilistic theory? Let's take a look at an experiment to find out. So here we have a polarizer with a polarized light source pointing towards it. If we rotate the light source, the light on this side of the polarizer grows dimmer or brighter. And if we set it at 90 degrees, the light on this side should completely black out, if you have a perfect polarizer. So to get a little more intuitive sense on how polarizers work, let's take a look at this string over here. Let's imagine that by plucking the string, we can visualize these waves produced as representing light waves. If we pluck it so it produces vertical waves, you can see that it easily passes through this vertical slot right here. And if we pluck it so it produces horizontal waves, you can see that it cannot pass through the vertical polarizer. It's the same with light. So let's get back to our experiment. The arrow on this lens indicates the direction of the polarization of the light source. And this dial shows the angle of the light source with respect to this polarizer. Let's say that we set the light source so that half of the photons coming from this polarized light source passes through and the other half are absorbed. If we send 30 photons through the polarizer, 15 will be absorbed while 15 pass through. So we get two different results. A photon is either absorbed or passes through. So we just lost determinicity. We can't predict if a photon will pass through or be absorbed, but we can predict the probability of it passing through or being absorbed based on the angle we set the polarizer at. But now you're probably wondering, how do we know that the photon passes through as a whole and that it isn't split in pieces? What could we do to prove that it, stays intact? The photon is an energy packet, so if it is split, the energy of the outgoing photon will be lessened, since some of the energy was absorbed. The Planck-Einstein relation states that the energy of a photon is inversely proportional to the wavelength. If the energy is reduced, the wavelength would change. The wavelength is related to the color of the light, so if the color changes, the energy must have changed. Here we set up 3 experiments with 3 different colors, green, orange, and blue. As you can see, the light's color remains the same, only the brightness changes. So we know for certain that the photon does not get split when sent through the polarizer, but that either the whole photon is absorbed or passes through. Therefore, the photon destroys determinicity and introduces probabilities. Max Born concluded in 1926 that quantum mechanics was probabilistic, and this view was largely accepted at the 5th Solvay Conference in Brussels, Belgium. But of course, there remain some scientists who were not pleased with the outcome.
I don't believe that God plays dice! Nor is it our business to prescribe to God how he should run the world.